Hi guys, Daniel here. So I'll mention about why in universities often Python is taught, and then there are better opportunities here for something maybe that can be used in production. All right, so Python has like a history since about 2000. One of the kind of key things is it's been like widely used. It's available for easy download, and of course comes installed in most distros. So it is of course very widely used. Also, it's of course well documented. One of the key things is like it's actually has excellent documentation, meaning that it's easy to understand and of course employ. It's of course fairly easy to use. There are fewer ways of doing things, which actually makes things really easy understanding, of course, and using it. Unlike Perl, by example, it's also a memory-safe language, so that there isn't any security issues with like using data after being freed. So it has like a bunch of benefits to it. Also, there are some issues as well with that. So it's in production at large scale. It often has like large memory usage. So that leads to like out of memory crashing on your like hosting or any containers. Also, it's not so efficient with a CPU usage, mainly because it's JIT compiled. And so it's a kind of like doing like very quick compilation step, so it can't be as heavily optimized. Also, many of you probably also experience issues with versioning and dependencies. This, of course, is like a kind of major problem these days. One solution is to have either a Python environment, which is like a kind of copy of all libraries, or like some vendors ship the whole Python release as well, like mainly for like ensuring no issues or compatibility problems. Also, so its types are inferred at runtime, so you can change like any type of any variable. That of course creates problems with compilation and also verification. So there are some problems which that introduces, making it kind of easier. So I'd say that Python is like an excellent learning tool, but also in production, say in cloud services, it could be like a bad choice. So how do therefore we define an excellent choice? So what goals do we have which help us navigate which choice, which like language is an excellent choice? So I'd say there are like 5 areas here. We have, of course, the developers here. So also perhaps people who would use the APIs. Sorry, language mechanisms. Of course, is it well documented? Are there any possible security issues? Also, support from the actual language itself. So, of course, some languages have less support than others. Also, going forward, is there any API guarantees? So, if in like say 10 years, if you compile your like your code, will it compile? So these are some of these elements which we should evaluate for a certain language. Fortunately, one of the more recent languages, Golang, that's now about 12 years old. It actually has a lot of these benefits. What I'll do is I'll run through some examples so you can see fairly easily what you can do with Golang. I'd say that it's also designed with like a network, cloud connectivity and like repos and APIs in mind. Okay, so how do you run things in parallel in Golang? So as you can see, this operator here called go is you can actually add that in front of a like function call, and then it'll actually run separate from any like code execution here. So in program order, you'd see that hello is called before world here. So like you of course would expect hello world as the output. But then when you actually run it, it's of course in the reverse, because hello is called in parallel with like world, and actually so executes later on. So what you can do is you can like scan the QR code, and then you can also like run the code yourself. So these like routines are called Go routines. They actually are like scheduled onto the like a processor cores. So it's like a kind of very efficient means of like scheduling thousands or up to like millions of like small functions or calls. That could be useful, like say for like processing like requests or like work units at scale. Okay, next up we have how do you use other modules in Go? Actually, all you have to do is reference the actual repo here. So you'll in this example, you will just simply mention this package called like Go figure on GitHub, and then you can actually use this directly in the code. And so here, what we do here is we then instantiate like a kind of object called figure, and then we like pass in some strings here, and then we call the function on that print. So when you build this with the command go build or go run, it'll fetch that package and also any packages that one uses as well. So it's like very efficient, very easy. So when you go run main.go, you will have the output. Once again, you can scan the QR code and then you can see the actual example. So it's very very simple actually. With of course this, you can you can build like big projects very fast. Okay, so say you have some code that you want to test. Now, obviously, unit tests are like very important. It's also very easy overlooking like adding tests as you actually write code. So in this case, we're looking at like factorials here. So factorial is the sum of all integers from the value that you pass. So how can we add a test for this? So you simply add a file with _test suffix there, and then you have a prefix here, test, before the function. And then what you can do is simply type go test, and it'll compile this unit test here and execute all unit tests. In this case, the test runs, all good, but then it actually finds that the value we expect is not correct. And that's because we should be including the top value in the loop. Should be less than or equals to. So actually really useful. You can have hundreds of tests. They can run either in series or in parallel. You can annotate them. Okay, so say you want to fetch a resource from the internet. So this in fact illustrates some of the power of Go. So in this case, we want to fetch a kind of joke string from an API. What we do is we have this HTTPS link here, and then simply this code is very simple. It will generate a HTTP request, a HTTP GET. Of course, it performs all the handshaking with SSL, so everything is checked and secure. And then it will pass the JSON into a struct here defined which has the like JSON elements. At that point, it then here what we do, this struct here actually has like 2 elements, so we can actually define a function based on that struct. So it's kind of like OOP. It's kind of like a class almost. And then you can literally just call print on that struct, and it'll then call this function here. So we of course like run this with like one command, and then it like fetches the object, the like JSON, passes it and prints it out. So actually very, very efficient. Something else here worth noting is Golang, you can return multiple arguments. So in C, you can only return 1. It's like really painful if you're like writing more complex code. Here, there isn't any limit. Also, it's worth noting that here we haven't defined any classes or any object orientation. So it's implied by having a function here, which takes a pointer to a struct. So it makes it very efficient for writing code. So how do you interop with libraries that are already existing? That's actually like really important. As an example, you have maybe a database library, you want to use it in Go. Actually very easy. You add a comment. This should be commented. Here. In like here, like main.go, you add a comment for the header file. And then import this cgo library. At that point, then you can just call c.hello in this case, and then it will call this function here compiled in this code. Yeah. So I actually agree. I have a typo here. Anyway, so the important thing here is you can integrate it with existing libraries very easily. So you can also use it in old projects, unlike newer projects, equally easily. This is something which like many languages, like Python, it's always been a little bit harder. Here is a list of all, like many of the features in the language, so just a quick tour of them. So if you want to install like a tool or like binary, you can actually just type go install and then the path to like GitHub, and then at the end latest, or a version string like which is tagged in Git, and then it'll fetch it. It will then compile it and any dependencies, and then it'll be installed into your bin directory very, very easily. It supports fuzzing, so very important for security. So you can actually automatically fuzz your functions, and of course find any edge cases, corner cases which may crash your code. Of course, earlier we showed unit testing. It also all your adepts are built into the binary. So what you ship is everything self-contained, no additional files, no versioning, and then you can capture the share of that, and then verify that is the complete binary with all the depths. So easier to handle. Also, say if you want to compile on like ARM or something like that, you can just add the prefix go arch equals ARM64 or one of the other architectures, and you can easily cross-compile. Some other notable things here is any unused variables or like type mismatches will fail compilation. That's good because it will save you time later, and it'll reduce the technical debt. Actually, the rest I think you can research yourselves, and it's actually a very rich set of features here. So In summary, I think Python is very good. It's a very easy entry point, I think, into programming. But then I think those skills may not be useful in production at scale. So there could be other opportunities. Golang certainly is one of them. Many like large projects now use that, and also like many cloud services. Like Grab, for example, all their infra is written in Go. There are some issues here also. I'd say that Python's versioning can be a problem. Has like definitely limits, but then also they actually have a lot of support there. Of course, like Go is though only 12 years old, so has much fewer projects out there, but is moving fast. Other opportunities could be Rust, but then Rust is also like very recent as well, also changing and evolving over time. But the problem is it's actually quite complex. So maybe something which is harder teaching in university, and maybe it isn't as like productive perhaps. So I'd say it's an excellent. It's definitely worthwhile looking into Go. Thank you. Any questions?